This is a neuron. These are the cells of the nervous system. Okay, so this is what's responsible for the sort of high-speed communication, long range in your body, okay? And they help you think when you're able to think. And it was a mystery for a while. How the hell do signals get through this thing? Okay? So signals come into this cell via the dendrites. They sort of accumulate in here, called the soma. They go to the axon hillock, where they're brought together, and then a signal gets shot. And the signal goes through what's called the axon, and that's the long bit that goes through the body, if it's that kind of nerve. Okay, so how do things get propagated in the axon, which I've mentioned before? Okay, and look at that. Okay, these guys won the Nobel Prize for this thing. Okay, they brought together oodles of stuff. They brought together experiment, they brought together theory, they fitted, and they predicted. So everything you want science and math to do, they did. Apart from the fact that some of their aspects of the model were a bit arbitrary looking. Okay, that's the model. Okay, and you will learn about this if you haven't already. You haven't learned about action potentials, have you? No. Okay, so the way a signal goes through a nerve axon, and I'll be fast about this, through a neuron's axon, a nerve impulse is an action potential. Okay, so it's a spike in voltage, which is what that thing on the top there is. Okay. So it's an all or nothing signal. So it might be a mystery to you how something can travel through the axon of a neuron as far as it might go and not lose power, essentially. Okay? And what you have is an all or nothing signal. So if you give it an input above a threshold, it'll fire. And it'll fire at full force, and that thing will propagate down the neuron. And that thing will look like that. Okay? So it's a spike in the voltage across the membrane of the cell. Okay. What causes this to happen, okay, in summary, are channels. So ion channels, which you may know about. Ion channels whose openness or closedness depends on voltage and time. Okay? So they open or close depending on where the voltage is, and over time their activity changes. Okay? So this is the conductance of those ion channels, how much ion they let through, okay, of potassium and sodium primarily. And this tells you how they activate and inactivate. Okay, so as those ion channels open and close, ions go in and out of the cell membrane and change the voltage across it, and that's how the signal gets made. So that's how you get an action potential, and that's the modeled action potential from all this crap. It may amuse you that the unit of resistance is ohm, so the unit for the inverse for conductance is mho. So ohm spelled backward. It's also called Siemens, which is funny if you're that kind of person. That's almost all I wanted to say. Bottom line is they won the Nobel Prize. This is a ludicrously important discovery. They brought together a whole lot of stuff, and they discovered this using what's called the giant axon of the squid. Okay, so it's this big axon that's found in those particular animals, and they found a load of experimental techniques, voltage clamps, that kind of thing, to discover this. And incidentally, you can get oscillations in the system, like the sort of Lynx oscillations we saw last week. Okay, so that's a bit of pretend enrichment. Ma'am?
Does that have like implications with like multiple sclerosis? Because isn't that when like axons aren't able to like fire?
You know what's going to happen? I'm going to look it up. Thank you.